Hello everyone, today we will be discussing an algorithm called dynamic programming. Dynamic programming, or DP, divides a problem into multiple subproblems and records the results to find a new answer. Though similar to recursion and brute force, DP has different implementation and can be optimized to reduce time complexity. The first step is to create a DP table, which is a 1D or 2D array that will store values from past calculations. Depending on the problem, there may be different ways to define the DP table. Next, the DP table has to be allocated with values through iteration. This can be challenging as there is no universal calculation which can solve all problems using DP. Let's look at a popular example of DP, the Fibonacci sequence. This is a series of numbers that starts with 1, 1, 2, 3, 5, 8, 13, and so on, where each number is equal to the sum of the last two numbers. The problem asks that given a positive integer n, find the nth term of the Fibonacci sequence. For example, if n is 6, the answer is 8. For this problem, we can use a 1D array where element I is equal to the ith number in the Fibonacci sequence. Initialize 0 and 1 as the first two values, or the base cases. Each number in the sequence is derived from the two numbers before it, so we need to iterate through and fill the table from left to right. This is the blank DP table we start with. First, we initialize index 0 with 0 and index 1 with 1. For each index I that follows, we set the value of I to value I minus 1 plus value I minus 2. So here we would set it to 0 plus 1 or 1. And we can continue to use this approach to fill in the rest of the table. Once we reach index n, we find the answer to the original problem, which in this case is 8 at index 6. Here's the code in C++. After taking the input, we initialize the first two values and then loop through the rest of the table, filling in values accordingly. Finally, we return the value at index n as the answer. Let's try another example. Given two words, we have to find the longest common subsequence or the longest ordered sequence of letters found in both words. For instance, if we look at the words sound and cloud, the longest common subsequence, OUD, is 3 letters. Here we will use a 2D array instead of a 1D array because we are comparing two strings. Each row represents a letter from string A, while each column represents a letter from string B. The value in dpij is equal to the longest common subsequence in string A up to the ith letter and string B up to the jth letter. The condition used to fill the DP table is that if I equals j, we set dpij to dpi minus 1, j minus 1 plus 1. Otherwise, we set it to the greater of dpi minus 1j and dpij minus 1. Let's look at some diagrams to understand this better. This is the blank DP table we start with using the strings from the example input. First, we initialize row 0 and column 0s to all zeros. Then we start filling the table based on similarities between letters. Because there are no similarities in this row, we can set these values to 0. The next row has some different results. Since both words have the letter O, we need to take our prior condition into account to fill in these values. Continuing with this logic, we find another similarity with the letter U and update the values. There's no new similarities in this row, so we can just copy from the row above. And finally, in the last row, we find one more similarity with the letter D, and our answer is 3. Here is the solution in code form. After understanding the logic behind it, the problem becomes much easier to understand and implement. Once again, we first initialize row 0 and column 0, and then we iterate through the DP table and fill it in using an if-else condition to compare letters. At the end, we can simply output dpnm as the answer. Here is a bonus problem that you can try to solve by yourself using DP. A thief with a knapsack of capacity W is trying to rob a store with n items. Each item has its own weight and value and can't be split into pieces. What is the greatest value of items that the thief can steal if the total weight cannot exceed W? For example, if the knapsack has a capacity of 5 and there are 3 items in the store, the thief can steal items 1 and 3 to get a total value of 8. Hopefully you've learned more about dynamic programming and will be able to use it to solve coding problems in the future. Thank you for watching.